got a lot to.
This time we're going to talk about depreciation and specifically the sum of years method. In the previous video we talked about the straight line method, which is much more easier compared to this one. So let's say you have a property and it has a useful life of 5 years. In computing the depreciation, we would multiply the cost by 5 over 15. So you might be wondering, did I got 15? We just add 5 plus 4 plus 3 plus 2 plus 1, and that's how you do it. And on the second year, the same formula applies, but the difference is that the numerator is only 4 years. Why? It is because 1 year has already passed, so we would deduct 1 year from 5 years. And the same thing goes, and so on and so forth. Knowing that 5 years is really easy to compute, what if the problem asks more complicated type of life, which is 50 years? Are we going to do the same thing? No, it is because it would really be time inefficient. It's really time consuming if you do our formula, which is 50 plus 49 plus 48 and so on and so forth. Instead, use the alternative formula. So we would do is add 50 plus 1 and divide it by 2, then multiply it by 50 itself. And the answer would be 1,275. So in computing our depreciation, we would multiply cost by 50 over 1,275. And on the second year, the same formula applies, but deduct 1 year from the numerator. Notice that when we're computing depreciation for sum of years, the depreciation tends to get lower as time passes by. That means the carrying amount of the property gets lower, but at a slower pace. So you might be wondering, which has a higher depreciation? Is it the sum of years or the straight line method, which we talked about in the previous video? The answer would be, it depends. It depends on the time actually. So just to give you a quick example so you could understand it more deeply, let's say in this graph, and the red part is the sum of years method and the blue part is the straight line method. On the first part, the sum of years method tend to have higher depreciation compared to straight line, but as time passed by, it would be the complete opposite. Why? Because while the sum of years is getting down, the straight line is just constant. So to give you a quick example, let's say we have Captain America right here. I'm pretty sure a lot of you know this guy, and he has a property which is the Captain's Shield. And its value is 5 million, and it has a useful life of 15 years. So we're gonna first compute for the denominator. So we would add 1 plus 15, then divide it by 2, then multiply it by 15. So the answer would be 120. That would be our denominator. So in computing our depreciation, what if we are asked what is the carrying amount at December 2019? We would just deduct the depreciation for 2018 and 2019. So as for 2018, we multiply the cost of 5 million times 15 over 120. And as for 2019, the same formula goes, but we just deduct the numerator of 1 year. So the answer would be, first the carrying amount of 5 million, then we deduct the depreciation for 2018, which is 625,000, then depreciation of 2019, which is 583,333. So the final answer would be 3,791,667. So that's it for the day, Countaholics. If you have any question, leave it down in the comment section below, and I'll see you on the next video.
No, it's too late, won't be going home. Keep on keeping on, get on your horse and ride. Rolling in deep, coming girls with me, popping champagne at the top of the limousine.